Do you know about the idea that all matter is inherently anthropic?
The idea that all matter is inherently anthropic is not a widely accepted scientific concept, but it may be related to the anthropic principle, which is a philosophical consideration in cosmology and physics. The anthropic principle is the idea that the universe's fundamental constants and laws of physics are finely tuned in such a way as to allow for the existence of life, particularly intelligent life. It comes in two main forms: the weak anthropic principle, WAP, and the strong anthropic principle, SAP. The weak anthropic principle states that only in a universe with conditions suitable for the emergence of intelligent life can such life exist to observe the universe. It is essentially a tautology, stating that our observation of the universe is possible only because the universe's conditions allow for our existence. The strong anthropic principle, on the other hand, suggests that the universe must have properties that allow for the existence of intelligent life, implying some sort of intentionality or purpose behind the universe's design. The idea that all matter is inherently anthropic may be an interpretation of the anthropic principle, suggesting that the universe's properties and the nature of matter itself are fundamentally tied to the existence of intelligent life. However, this idea is not widely accepted in the scientific community, as there is no empirical evidence to support it. Most scientists and philosophers consider the anthropic principle as a philosophical observation or an interesting perspective, rather than a fundamental law of nature.
I think what you've described about the anthropic principle is accurate, but it wasn't what I meant. Can you take another stab at it?
I apologize for the confusion. It seems I misunderstood your question. Based on your query about the idea that all matter is inherently anthropic, it sounds like you might be referring to a concept known as panpsychism. Panpsychism is a philosophical theory that posits that consciousness or mind-like qualities are inherent in all matter, not just in complex organisms like humans. According to this view, everything from subatomic particles to the entire universe possesses some form of subjective experience, albeit at different levels of complexity. This idea is rooted in the notion that consciousness is a fundamental property of the universe, similar to mass or charge. Some proponents of panpsychism argue that it offers a potential solution to the hard problem of consciousness, which is the question of how and why subjective experiences arise from physical processes in the brain. It's important to note that panpsychism is a philosophical theory rather than a scientific one, and it remains a minority view in the field of philosophy of mind. While it has gained some attention and interest in recent years, it has not been widely accepted by the scientific community, mainly due to the lack of empirical evidence and the difficulty of testing its claims. If this is not the concept you were referring to, please let me know, and I will do my best to address your question more accurately.
That's not quite what I mean either. I wonder if I'm using the wrong words for it. Can you take another guess?
I apologize for any confusion. Given the information you've provided, it's challenging to pinpoint the exact concept you're referring to. However, I will try another interpretation based on your question about the idea that all matter is inherently anthropic. It's possible that you're referring to a concept known as biocentrism. Biocentrism is a philosophical theory that posits that life and consciousness are fundamental aspects of the universe, and that reality, as we know it, arises from the interplay between these elements. In this view, the universe and its properties are shaped by the existence of life and observers, rather than the other way around. Biocentrism, which is primarily associated with the ideas of Robert Lanza, a medical doctor and scientist, contends that our understanding of the universe and its laws is inherently anthropocentric because it is influenced by the nature of our conscious experiences. This idea challenges the traditional scientific view, which assumes that the universe operates independently of observers, and that life and consciousness are emergent properties resulting from complex physical processes. While biocentrism raises thought-provoking questions about the role of consciousness and life in the universe, it remains a speculative and controversial theory. It is not widely accepted by the scientific community, as it does not provide a solid empirical foundation or falsifiable predictions to support its claims. If this is still not the concept you are looking for, please provide more information or context, and I will do my best to help you find the right answer.
I don't like biocentrism either. Let me describe what I'm saying in a few more words. I think matter inherently seeks to know more about itself. That is what interaction is. The fact that matter interacts with matter is what is anthropic about it. By interacting with itself, it creates more knowledge about the universe. The more knowledge that is created, the more that matter can know about the universe that it exists in.
Thank you for the clarification. Based on your description, it seems like you are proposing an idea that suggests matter has an inherent drive to interact with and understand itself, contributing to the creation of knowledge about the universe. This idea does not have a direct analog in existing scientific theories or philosophical concepts, but it touches upon elements from various fields of thought. In some ways, your idea resonates with aspects of panpsychism, as it implies that there might be some fundamental property of matter that seeks understanding or interaction. However, your idea goes beyond panpsychism by suggesting that this interaction leads to the creation of knowledge about the universe. Additionally, your proposal also bears some resemblance to ideas from complexity theory and emergence. Complexity theory studies how complex systems and patterns can arise from simple interactions among components. Emergence is the phenomenon where novel properties and behaviors arise from the interactions of simpler constituent parts, which do not exhibit those properties individually. In this context, you could argue that the drive for matter to interact and understand itself leads to the emergence of increasingly complex systems, culminating in the creation of knowledge about the universe. While your idea is interesting and thought-provoking, it is important to note that it falls outside the realm of established scientific theories and philosophical concepts. As such, it is a speculative notion that would require further development and empirical support to gain wider acceptance in the scientific and philosophical communities.
I think you've got a grasp on it. Let's explore it. Can you brainstorm a few scenarios in which we could generate empirical support for this?
Certainly. To explore the idea that matter inherently seeks to know more about itself through interaction, and that this process contributes to the creation of knowledge about the universe, we would need to identify testable hypotheses that could provide empirical evidence for this notion. Here are a few potential scenarios. Identifying a fundamental property of interaction. One approach would be to look for a property or mechanism that drives matter to interact and seek understanding at the most basic level. This would involve studying the behavior of elementary particles and their interactions, searching for patterns or characteristics that suggest an inherent drive towards creating knowledge. This could involve using advanced particle accelerators, quantum computing simulations, or other cutting-edge experimental techniques. Investigating emergent complexity. Another strategy would be to examine complex systems that arise from simple interactions among components, focusing on how these systems generate new knowledge about the universe. This could involve studying physical, biological, and social systems at various scales to identify common principles or patterns. A key challenge would be to establish a clear link between these emergent properties and the inherent drive of matter to interact and understand itself. Developing a quantitative measure of knowledge creation. To support the idea that matter's interactions lead to the creation of knowledge about the universe, it would be useful to develop a quantifiable metric for knowledge creation. This could involve assessing how the complexity of a system, or the amount of information generated by its interactions, correlates with its capacity for creating knowledge. Such a metric would need to be robust and applicable across various domains and levels of complexity. Creating artificial systems to test the hypothesis. Designing and studying artificial systems that mimic natural processes, such as cellular automata or neural networks, could provide insight into the proposed idea. By manipulating the rules governing these systems and observing how they evolve, researchers could investigate whether there is a trend towards increased interaction and knowledge creation. This could help establish whether the proposed concept is a general property of matter or specific to certain types of systems. Comparing the development of knowledge across different scales. Studying the evolution of knowledge and information.
That's an interesting point 4 you've got there. Gee, I wonder what kind of artificial system could we create to test this hypothesis?
To test the hypothesis that matter inherently seeks to know more about itself through interaction, and that this process contributes to the creation of knowledge about the universe, we can create an artificial system that simulates the interactions between simple components, allowing them to evolve and generate complexity over time. Here are some examples of artificial systems that could be used to test this idea. Cellular automata. Cellular automata are simple grid-based models where each cell follows a set of rules based on the states of its neighboring cells. By defining different rules, we can observe how the system evolves and generates complex patterns from simple initial conditions. Cellular automata, such as Conway's Game of Life, have been used to study the emergence of complexity, self-organization, and information processing. Researchers could investigate whether certain rules or initial conditions lead to a trend towards increased interaction, knowledge creation, or information exchange within the system. Artificial neural networks. Artificial neural networks are computational models inspired by the structure and function of biological neural networks. They can be trained to process information and learn from data. By studying how these networks self-organize and adapt their connections to improve their performance, we could investigate whether their interactions contribute to the creation of knowledge and understanding of their environment. Furthermore, researchers could explore how different network architectures, learning algorithms, or training environments affect the network's capacity for knowledge creation. Agent-based models. Agent-based models are computer simulations where autonomous agents interact with each other and their environment following a set of rules. These models can be used to study complex systems and emergent behavior in various domains, such as biology, ecology, economics, and social sciences. By designing agents that represent simple components of matter and defining rules that govern their interactions, we could study how the system evolves and generates knowledge over time. Researchers could manipulate the rules, initial conditions, or environmental factors to explore the relationship between interaction, complexity, and knowledge creation. Genetic algorithms. Genetic algorithms are optimization techniques inspired by the process of natural selection. They involve a population of candidate solutions that evolve over time through mutation, crossover, and selection based on their fitness. By designing a genetic algorithm that seeks to maximize some measure of knowledge creation or information processing, we could investigate the relationship between interaction, evolution, and the generation of knowledge. This approach would require defining a suitable fitness function that captures the desired aspects of knowledge creation and system complexity. These artificial systems provide a starting point for testing the hypothesis that matter inherently seeks to know more about itself through interaction, and that this process contributes to the creation of knowledge about the universe. It's important to remember that these models are highly simplified representations of real-world systems, and that their results should be interpreted with caution. However, they can offer valuable insights and help guide future research into this unconventional idea.
In conclusion, we had an interesting discussion about the topic of whether matter is inherently anthropic. We explored different perspectives and considered the role of AI in understanding and advancing our knowledge in this field. As always, it's fascinating to engage in philosophical and scientific debates, and I hope this conversation has been thought-provoking and insightful for all involved.